Hi guys, my name is Delaney and today I'm going to talk to you guys a little bit about how our eyeballs let us see the beautiful world around us. So our eyes has some amazingly simple technology that it uses to let us see everything, some amazing things. And today we're going to talk about how our eyes let us do that. But first, we need to talk about light rays. Now, it sounds crazy, but light rays actually come from our sun. Our sun sends down these little curvy rays down to the earth, and it comes down, and then what it does is bounces off different objects. So a light ray will come and bounce off of my leaves of my plant, right? And then those rays go into my eyes, and that's how I'm able to see that. That's how I'm able to see everything around us. And so we're going to talk about how our eyes take those light rays and tell our brain to see the object. The cornea. So the first part we're going to talk about is arguably the most important part of our eye, and it's the cornea. It is much like this saran wrap that I'm holding. It's a clear layer that goes over the other parts of our eye, and it not only stops things like eyelashes or dirt from getting into our eyes, but also makes sure that all of the light rays that are bouncing all over the place aren't crazy in our eyes. And what it does is it's a curved shape, because as we know, our eyeballs are actually kind of like a circle. And that curved shape lets the cornea grab all those light rays and is like, stop being crazy, and puts them through the pupil. If not, they just kind of be bouncing all over the place and we wouldn't be able to see anything. And the funny thing about the cornea is when it gets all those light rays like off the plants, it actually flips the images upside down. So to our eyes, like my plant back here is actually upside down. And I'm going to kind of show that to you and explain to you why it does that. The object here that I was holding earlier, as you can see, turns all of the objects upside down, which is very similar to what our cornea does. So as you can see, my little plant right here, our cornea does what this does, and it turns it upside down. And it's because of not only its circular shape, but because of the light rays bouncing off of these objects, when they come into our eye, they're actually upside down. The iris and the pupil. So now we're going to talk about our pupil and our iris. So first we're going to talk about the pupil. Believe it or not, it's not just a dot in our eye. It actually has a huge purpose. So in order for the light rays to actually get to the backs of our eyes, there needed to be a pathway to go through the eye. And the pupil allows that. It's pretty much a tunnel for the light to pass through in order to reach the retina and the parts in the back of the eye. And now the iris plays a huge part in our pupil. So you know that feeling when you walk outside and you're like, oh my gosh, there's just too much light and it's too sunny, and you like squint? Well, the reason why is our eyes are actually really, really sensitive to light, and they can actually be damaged by too much sunlight. So the iris shrinks our pupil, so barely any light can get through the pupil to our eye. And that stops our eyes from getting damaged and overwhelmed by the amount of sunlight. Now, almost the opposite thing happens at night. When it's dark outside, we need as much light as possible in order to see. So our iris, makes the pupil larger. And what that does is it allows more light to pass through the pupil and to the back of the eye. And that makes sure we can actually see stuff. Now, if our pupil stayed the exact same size the entire time, we would get too much sunlight in our eyes and we could become sun damaged in our eyes, but also we would have terrible night vision and we would not be able to see at night, and it would just be pitch black. Pretty cool, right? So after the light goes through our iris and our cornea and through our lens, it has to go through this very thick gel that we have in our eyes. And the reason why we have this gel is so that our eyes can keep its eyeball shape. Without it, it kind of be like a deflated balloon, and that wouldn't be very useful, and we don't want that. And so this gel keeps that shape. So after the light ray passes through this gel, it hits this thing called the retina. And the retina is the messenger. And so what it does is it accepts that message from the light ray. And let's say the light ray is a light ray from a plant. And so it hits the retina, and the retina's like, yes, we're looking at a plant. And so what it does is it takes that message and runs to the brain and says, brain, I have a message for you. And then the brain opens that envelope and is like, oh, she's looking at a plant. And then it registers that we're looking at a plant. It's really, really cool. Eyes are so cool. And they seem just like some random little ball we have in our head, but in reality, they're an amazing thing that we have in our body. And all it really does is it takes light. Pretty awesome. So I hope that you enjoyed this video, and I hope that you enjoy now knowing how our eyes work. And I hope you guys are all safe. I hope you're washing your hands, and please be nice to your parents. Bye, guys.